everyone, welcome to the Molec-Cell Podcast. I'm Ronalyn,
And I'm Michael.
and today we're talking about a really interesting forensic case study I read recently.
Oh, really? What's it called?
It's called Species Identification from Seized Animal Oil, a case study of suspected gangetic dolphin, and it was published in the International Journal of Legal Medicine.
Animal oil. Like they tested out oil and then figured out what animal it came from or something?
Yep, exactly. It's actually a big deal in wildlife forensics. This study looked at oil that had been confiscated during an anti-poaching investigation in India.
Oh,
Yeah, officials suspected it came from a protected species, the Ganges River dolphin. But oil is one of the hardest materials to test because DNA is usually super degraded. So this research shows how scientists actually work through that challenge.
wow, that already sounds wild. Let's get into it.
Okay, so first, some quick background information. The Ganges River dolphin, also called susu or bulan.
So they want they want the oil from the dolphin for something?
Mm-hmm.
Oh,
Yeah.
the poachers.
Yes.
Okay.
So the Ganges River dolphin is endangered and protected under India's Wildlife Act. Poachers still legally hunt them mainly to extract their oil. The oil is used in traditional medicine and as bait for catfish. So there's a big black market for it.
Oh, wow. But the oil seems like a terrible sample to test, right? Because there's not very much DNA and it's degraded, you said?
Yep, exactly. Oil usually has almost no DNA left in it, and it's full of chemicals that block testing. So this kind of sample is considered very hard work to work with.
Oh.
The forensic team received the oil and tried to extract DNA from it using modified methods. They only recovered a tiny amount, like 2 to 3 nanograms per microliter.
Oh, wow, that's nothing.
Yep, which is barely anything. But it was just enough to attempt PCR.
Wait, what's PCR again?
Good question. PCR is basically a DNA copy machine. It stands for polymerase chain reaction. When scientists start with a tiny bit of DNA, PCR makes millions of copies so they can analyze it.
Oh, because they can't analyze a tiny bit of DNA.
Mm-hmm.
They need more.
Without PCR, there wouldn't be enough DNA in this oil to identify the species.
Oh, so they duplicate the DNA that's in the oil.
Mm-hmm.
Got it. So PCR makes the DNA readable.
Exactly. So they amplified two mitochondrial gene regions, the site B and 16S rRNA, because those genes are commonly used to identify species. Once they sequenced those DNA fragments, they compared them to reference sequences in the NCBI BLAST database. Both genes showed more than 99% similarity to the Ganges River dolphin. They even built a polygenetic tree to confirm the sample clustered with dolphin sequences.
Oh, so they were able to prove that the oil came from the endangered dolphin, right?
Yep, scientifically and legally.
So the poachers went to jail.
Hopefully.
Guilty.
Guilty right away. So that's what the study found. But stepping back, it's helpful to look at what the researchers did well and where the method still has limitations.
Yeah, because they were successful, but it was still difficult.
Yep. First, the strengths were they successfully extracted DNA from a sample type that usually fails. They used two genes, which makes the species ID more reliable. They backed their results with multiple approaches: the blast matches, genetic distance, and phylogenetic tree. and the work has real world impact. It directly supports anti poaching efforts.
Yeah, that's great for conservation.
But there were also limitations, though. The DNA yield was extremely low, so PCR failure was always a risk. They only had partial gene fragments. More genes or longer sequences would add confidence.
Hmm.
And the method relies on reference database availability. If reference sequences are missing, identification becomes harder.
Oh, so the method works, but it's a fragile method.
Exactly. It's promising but not foolproof. The big takeaways is that even oil, a really degraded sample, can still hold enough DNA for species identification if processed carefully. That opens new possibilities for wildlife forensic cases where only oil, powder, or processed products are seized. Future work might include improving extraction techniques, using multiple genes, and building better reference libraries so species identification becomes even more accurate.
Yeah, that's really cool how something as simple as identifying the source of oil can have a huge like impact on conservation and send the right people to jail if they're guilty.
Exactly. It's a great example how molecular biology supports real world wildlife protection. And that concludes the overview of this case study. Thanks for listening, everyone. If you enjoyed today's episode, make sure to tune in next time for more science stories and case studies. See you all soon.
Bye everyone.
Bye.